Hello everyone, my name is Everton. Welcome to the GG Annual 2020. In these sections, we will have the presentation by Natalie CACCIOPPOLI with the title Pegasus, Dual Frequency, Multi-Constellation, Gbas Evolutions. I remind everyone to ask the questions in the comments, help us share the event link, and leave your like. So, Natalie CACCIOPPOLI studied radio, electronic navigation, and telecommunication engineer at the Università degli Studi di Napoli Partenope in Italy, in the same university. He was a fellow researcher in the engineering schools granted by the Italian Aerospace Research Center, work on Igneous signal in space. Now, CACCIOPPOLI is GNSS Operation Validation Expert Consultant at the Eurocontrol Experience Center in France, where he is the leader of Eurocontrol Pegasus team. Okay, Natalie, thank you very much. Can you start your presentation?
Yeah, thank you very much, Weberton, for the very nice introduction. And I wish to thank you, Renan, and Professor Galera for the great organization and timing, and for the opportunity. So I do share my presentation. Can you see it right now? Is it okay?
Yes. Okay,
right. So I hope I will take you and all the audience passionate with Pegasus with my presentation, which will focus on Pegasus. We will see what is Pegasus, and mainly on dual frequency multi-constellation Jibas evolutions. So I will introduce not only Pegasus, the current activities status of the research on the Jibas. Notably, we will see briefly what Jibas does actually, what could do, and then thanks to the experimental installation of Professor Galera and Weberton in UNESP universities with some receivers in there that reproduce the main configuration of Jibas station. We will go together in analyzing the preliminary data results, and it will be my objective just to show you what you could do with Pegasus and how I can help you to achieve, I hope so, your research objectives. So let's go. So what is Pegasus? Pegasus is a tool for processing GNSS data collected in flight and on the ground. Pegasus uses standard algorithm from MOPS, stand for Minimum Operational Performance Standards, for GPS, Galileo, SBAS, Jibas, and in the very close future, ARAIM as well. ARAIM is Advanced Receiver Autonomous Integrity Monitoring. The Pegasus tool includes a standardized graphical representation of the results that I've been able to achieve thanks to the contribution of users like you are or you will be, I hope so. And Pegasus actually is a tool that is used as the reference GNSS processing by many organizations, and then we will have a look more in details in the later slides. And essentially, the Pegasus tool has contributed to the validation of the European SBAS system, EGNOS, in 2010, and currently Pegasus supports the validation of Jibas GAST-D and development towards dual frequency multi-constellation GNSS applications. And here in this presentation, I will focus mainly on Jibas GAST-F. Sorry to introduce all those aeronautical acronyms like Jibas, GAST. We will see later on what does it means about, but GAST-D, does it means Jibas approach service type, which define the category approach to which is intended to provide a given service from the Jibas system. So next slide. Which are the objectives of Pegasus tool? First of all, it's about education of service provider and regulators, of course, in the aviation sector. And then validation of International Civil Aviation Organization and Radio Technical Committee of Aeronautics Association and Euroguide European One standards. So this means that the ICAO, International Civil Aviation Organization, does standard and recommended practice. This means that once those are issued, for example, for GNSS application for aviations, to ensure that interoperability is met in each country, because a plane can fly directly from Napoli, where I was born, directly to Sao Paulo, for example. And then if in Napoli there is SCAT1, I will explain you later, Jibas CAT station, this is for military application only, for NATO bases is there. And I hope one day there will be a Jibas station in there, but we need to assure that the airborne receiver that is on board the aircraft that Natalie is taking from Napoli to Sao Paulo is interoperable with 2 Jibas stations that could be built by different manufacturers, as well as the airborne receiver on board the aircraft is built up from another manufacturer. So interoperabilities. That's why the ICAO, when does issue SARP, standard and recommended practice, local regulators have to employ those regulations, and those are done by RTCA, a Eurocontrol standard, that it means translation of those standards in local regulation. So to make sure that the aviation operations are safely enough, that they use exactly the same information the same way on both airborne side, ground side, at any place, anywhere in the world, I mean, all global. Pegasus also supports state campaign to validate GNSS performance. This means that when a GNSS system has been standardized and then deployed, with Pegasus we help air navigation service provider like DSEA in Brazil. We did already, for example, some studies for GPS, nowadays Galileo, and then also Jibas as well, to help them and to verify if the performance for an aviation application, for example, for landing, CAT1 or CAT2-3, those are very well fulfilled, like is stated in the standards. As well as the Pegasus tool enable exchange of comparable results for faster accumulation of relevant statistical data. This means that if you process data with your receiver that has a given binary proprietary format, I can reuse it and then to provide directly to the Pegasus team laboratory, CNS lab nowadays is called, for fast analysis and support as well. But even with any other Pegasus user, you can interchange your data, as well as there is not a disclosure agreement on the data, but this is a legal matter that is outside the objective of this presentation. And then so another objective is verification of augmentation system performance, as I said, so as such as Gbas and the Jibas nowadays for GPS and Galileo and RAIM technology. Pegasus tool is as well as independent from manufacturer and service provider. We try to keep track of the changes that manufacturers they do about the laboratory receivers, like Professor Galera and Weberton, they own for their Jibas experimental installation, but as well as for equipment on board the aircraft that is called MMR, that stands for multimode receivers, as well as for VDB, VHF data broadcast information for Jibas on board the aircraft, and different manufacturers on the ground. So Pegasus nowadays is evolving to support the Jibas and Gbas CESAR research activity, where CESAR, it's the huge European single sky research activities that has the objective to renew all the, let's say, on my side, the CNS components of air traffic management. CNS stand for communication, navigation, surveillance, and I do stand in the navigation side. So let's go to the next one. So Pegasus, what does provide? Pegasus provide processing according to published standards, as already said, simplified automated processing, scheduling of processing. This means that sometimes it takes a while, some module of Pegasus. This means that during the day, you normally work with your PC in your office, and then during the night, you launch a Windows task manager, and then you can run different tasks of Pegasus automatically. And then in the morning after, when you take coffee in the office, you can look at the report generated by Pegasus and then to analyze the data. So this means, most important things, that Pegasus is a post-processing tool. It doesn't work in real time. It's only post-processing. In real time, we have some applications when we do flight approach data analysis, but it's just for data collection, but not for data analysis. So it's only post-processing tool. I already said that is manufacturer independence. There is a module of Pegasus that converts a set of binary proprietary format manufacturer standards into Pegasus format. The Pegasus format, it's very easy. It's a text format, CSV, comma separated value, that you can open with any kind of editor that you would like to use. But I just suggest you to use, for example, the file watch module of Pegasus. We will see later. Modularity standards and open interfaces of Pegasus. So Pegasus is a collection of modules that you can combine between them and then address a given needs. We will see also this later. So also is adaptable to changes in the standards. So this depends essentially from me. As soon as there are new standards published by one of the organizations I cited before, I will have to change inside the algorithm of Pegasus to respect the standards and to make available the air navigation service provider manufacturer in the aviation sector to verify that performance of augmentation GNSS are very well fulfilled. And Pegasus also supports users in varying needs. This means GPS, Galileo single frequency, dual frequency, S-Bus, Jibas, A-Rain, Gbas station simulation, for example. This is the objective of this presentation, and many others, for example, multipath analysis, and nevertheless, a little bit even of the ionosphere assessment and so on. With Pegasus, when you will be asking me for Pegasus, this is for free. It's license free. You don't pay for it. We do provide for free. Even the support is for free as much as I can, because I have to work even on many other things, not only Pegasus in Eurocontrol, but it will be a pleasure to support you as much as possible I can in the short term. So Pegasus provides you not only the modules, the tool, to process and analyze the data, but also full documentation that describe the algorithm implemented and the current update with the standards. Indeed, Pegasus is developed in close cooperation with users. This means that in our collaboration with UNESCO universities, if your expertise on space weather and data analysis information like with the ionosphere, you see that some parameters are worthwhile to insert in Pegasus, as well as some plot that gives a glance on the analysis of data. I will be very pleased to implement in Pegasus, but this will mainly depend from the availability and the priority about my task in Eurocontrol. So anyway, Pegasus toolset in a nutshell. So Pegasus provide a series of modules on board the aircraft, as you can see here, and on the ground. On board the aircraft, we have the main modules. Those are converter and GNSS module. Converter, as say the name, take the proprietary binary format from several manufacturers to Pegasus format, or as well as from Rhinex format, for example, and then it does convert in Pegasus format. And then with the GNSS solution, we are able to process, for instance, S-Bus information coming from a geo satellites. EGNOS was, for instance, we have tested even with many others Gbas LAAS system. It's wide area augmentation system, but in general, with Gbas system all around the world, it did work very well, since we do respect the standards as much as I can. And then we can do also position solution with the Jibas, with the different Jibas approach service type. This is the case for CAT1, GAST-C, CAT23, GAST-D, and nowadays with GAST-F, that means using GPS, Galileo, dual frequency, or single frequency. This is the airborne side. On the ground side, we don't have a module that is capable of simulating S-bus messages, but we have everything we can do for Jibas, for instance. Indeed, the Jibas messenger is the latest toolset, module of Pegasus that for time being Weverton is testing for me. Is the first beta tester ever, thanks to him and Professor Galera, and it seems starting to work well, but it's still not consolidated yet. That is a module that enables you to generate Jibas messages as a Jibas station would do for any kind of service, GAST-C, D, and F, depending on the availability of the information. This means that the Jibas messenger is able to produce GAST-C, D, so CAT1 and CAT23 messages, if at least L1 GPS information are present in the data. And if those measurements include also GPS L5 and Galileo E5A, it will generate automatically also the messages for GAST-F applications. This is the case for a simulation of Jibas station and analysis of Jibas performance at your premises if you don't have an aircraft equipped with an MMR and Jibas enabled and Jibas station, and then you own just 3 or 4 ground receivers in fixed position. But Pegasus also provides for Jibas application other 2 modules. This is CAP module, that it means compute accuracy prediction, and PGM. PGM stands for process Jibas messages, which those are used by air navigation service providers that provide operational services. This means they land in their aircraft with a Jibas, a true Jibas station certified in there, and those modules, they do provide a glance on the ability of their Jibas station to provide the service level is required with the CAP. And the PGM module verify that the standards of the message broadcasted by the stations, not the standard, the format of the message and data content fulfill exactly the standards as is issued, for example, in minimum operation performance standard document 243. Don't worry about all those acronyms and numbers. I have put it in later slides. You will have all the reference about these ones. So let's proceed. Pegasus users support task. We do support standardization and regulatory activity. Indeed, me and David, we do participate in the RTCA SC 159 GNSS working group, Eurocontrol working group 62 for Galileo, for Jibas, technical standard orders, offline compliance verification as well, and mainly we do contribute to research European project CESAR 2020. Pegasus and me especially and David, we do support system test and validation both in laboratory and operational environment. We do also grounded airborne navigation performance assessment, system interoperability assessment. As I said, for example, an aircraft is equipped with an airborne receiver that it was built from manufacturer A, and the Jibas station is manufactured by a manufacturer B. Sorry to play with words. And then we do assess with Pegasus the interoperability to ensure the safety of air navigation, where in that airport, for instance, S-bus or Jibas operations would like to be implemented. What I'm specialized, especially myself, it's anomaly investigation and mitigation technique using Pegasus, helping the users of GNSS augmentation to understand why we don't have availability or continuity of the system, or, for example, if there are misleading information. This is a particular condition on the integrity point of view. And then we also support the users with management and development of methodology additional tools. We can just produce some tools just for you to let you use Pegasus in function of the format of data. This is an example. For example, Weberton had a problem to filter out Galileo data from the old module of Pegasus that just produce GAST-C and GAST-D messages, and he couldn't do, but David, my colleague of Pegasus team, did an ad hoc tool to let Weberton filter out Galileo, and then initially Weberton was able to successfully process the message with GPS L1, but now there is a Jibas messenger that replaces the old module. So this is just sorry. So about the user community, Pegasus user community is all around the world, and we are very pleased to have you too, and hope to have many others in Brazil. And we do help mainly public-private research institution, and notably the aviation industry sector, with manufacturer of airborne and ground components for Gbas and Jibas, and notably for any other GNSS application like ARAIN2 and so on. So the Pegasus contribution to CESAR. What is CESAR? CESAR is a single European Sky ATM research program with the objective to completely overhaul the European airspace, with the objective of improving the ATM, air traffic management performance, and to make a better and intelligent air transport system all over Europe, but not only. We do work in close cooperation, for example, with our colleague of the FAA with the next gen. So this means that, of course, when you do a new solution, you have to be sure that this solution is fully interoperable with any others similar, the same solution in another country all around the world. So the CESAR project generally see three phases: the definition, development, and deployment. Nowadays, we are in development phase called CESAR 2020 Wave 2 of CESAR. And the other two pillars, definition and deployment, they do currently change for each phases of the project to address the challenging environment of providing a more reliable, high-performance GNSS augmentation system, such as the Jibas ones. Let's see where Pegasus did contribute for Jibas, CACCIOPPOLI, and DFMC airborne ground contributions. Those were since 2008. And started with GAST-D, initial research and development, and then we passed in the period 2014-2020 for the deployment of GAST-D prototype stations that they are now more advanced than a prototype. Indeed, European manufacturer already applied for type certificate approval from the FAA, so certification could come in the next years. I say next years just because those procedures of certifications are quite delicate, complex, I would say, and though it's very difficult to demonstrate compliance of the prototype to the standards, and notably to the ionosphere resilience of GAST-D system that look for improving the performance of Jibas CAT1. So, and nowadays in the deployment phase, wave 2, we do support the GAST-D extended scope and the GAST-F final research and applications that will run until 2022. And here below, I just show you the current Eurocontrol stakeholders or project 14 Wave 2. solution 79. Sorry to state all those numbers, but this is important. If you wish to retrieve any information from the CSAR joint undertaking website for solution 79, I'm not sure that everything is public, but some material could be available in there to download and to understand. Otherwise, you can ask directly myself, the Pegasus team, or my line manager, Andreas Lipp, is responsible for Jibas in Eurocontrol, and he will be pleased to help you with the requested documentations. So, Pegasus doesn't work only in a laboratory in Bretigny-sur-Orge, close to Paris, but we do go also on the field. And those are just some pictures of myself working on the Jibas Gas-D airborne and ground prototype performance analysis, interoperability test, where here we were working on the ground and airborne test using the Jibas station prototype from European manufacturer, and the airborne prototype receiver for Gas-D from a European-based US wild and well-known manufacturer in there to assure interoperability and performance assessment with Pegasus. So here, which is the current status of activities and deliverables? Actually, the last version of Pegasus 19.07.03 or patch 25, it also includes all the analysis and definition of Pegasus test and development requirement for the latest approved version of GAST-CD SARPs and MOPs, version 253D and 246E. So the first document, this is the mandatory document to understand the GNSS solution, of which I provide full description in the Pegasus design justification documents. It's provided documentation of Pegasus, as well as 46E that provide the the Jibas ground station ICD interface control documentation, notably for the format of the messages transmitted and their content. So actually, the latest public version 19.07.03 does include the Jibas messenger that I delivered to Professor Galera and Weberton yet, because I'm still consolidating it and still solving some few bugs, but it looks it's going well. So that version 19.07.03 really contained the initial version of Jibas messenger that it's really slow. It means that for 1 day of data, it can take at least 16 hours or something like this, or an entire day. It depends if it's single frequency, dual frequency. But 2-day version Jibas messenger, whatever data is provided in it 1 day, or single or dual frequency, it takes just 1 hour and a half. So a great improvement I've been able to do there for a better user experience. So that version of Pegasus, as well as contained the new multipath module algorithm update, as it was requested by working group Eurokai working group 28. This is very important for Jibas data analysis, the multipath analysis models. As well as I have updated the interface control document with the new message content and format for Jibas, for instance, and all the algorithm for airborne processing. And for the ground processing, it will be maybe the next version of Pegasus. I have to see if I have time to write and update the document to the new GAST-F processing of the Jibas. And of course, in parallel, we do support the Pegasus users in the CSAR project via email, WebEx, short training session, as well as I can do with you, of course. It's foreseen next March an extended seminar with more details about Pegasus, in which we foresee to do a couple of hours per week, but let's see yet if it can be done. I'm really much willing to do it, and I'm committed, already booked in the calendar. So no problem for this. I will try to do it as much as possible. And then provision of quick patches of Pegasus, like I'm doing actually with Weberton. Each time I found a problem, I do compile a new version and providing it soon. And then in the meantime, we will test. And only when there is a consolidated version of Pegasus, I will deliver the new version. So this slide just wish to show you the implementation status of Jibas, and then I invite you just to have a look to the light green points and the dark green. The dark green points show you the certified and operational Jibas GAST CAT1 Jibas station, and the light green, those are operational GAST C, which are national and private. Here, I believe that those dots in Brazil, it's our colleagues from IACIT, that they are working with Pegasus, with their Jibas station, and then we'll have to update in flygls.net website, even a dot for in Sao Paulo for your activity too. Soon, I mean just after Christmas holidays, I hope so. And so the groups that do support the Eurocontrol stakeholders in Jibas sector are the LATO group, Landing and Takeoff Focus Group, and as well as the International Jibas Working Group. The LATO take place twice a year in Europe, mainly at Eurocontrol headquarters in Brussels or in Bretigny-sur-Orge, where we work. It's close to Paris, France. And the International Jibas Working Group mainly is hosted in once per year, I mean, once in Europe and once in US or in another country, international, outside Europe and US, they're willing to install a Jibas station or with a serious program of doing it. So you will have to have a look on the flygls.net website to know the schedules of those meetings, but no problem, because Weberton and Professor Galera, they are already members, and they will know exactly when there are those groups meeting, and then can broadcast you the information. And if you wish to join, just send a request to Professor Galera, which will forward to me and David, and will make you also a member of those groups. So the Jibas in a nutshell. Jibas is a ground-based augmentation system. The ground-based augmentation system is composed mainly from 4 reference receivers on the ground that collect the data in parallel with the receiver on board the aircraft, that at the same time see the same GPS or Galileo satellite in the sky. They do measure the pseudo range, they compute corrections for accuracy, as well as the parameters to guarantee integrity on board the aircraft. So single measurements, let's say on L1 for today existing Jibas certified and approved Jibas systems, that do provide the measurements to the Jibas ground facility, that is a station. It's not more than a rack with a PC and a VDB transmitter that compute corrections, integrity informations, and it broadcasts those information via a VHF antenna. It's that one, VDB antenna, VHF data. It's VDB stands for VHF data broadcast signal. So this means that the aircraft on board, it's equipped with an MMR multimode receiver. Multimode just because the receiver on board the aircraft reproduce the indication on the main indicator in the cockpit of the pilot, exactly the same deviation like the ILS instrumental landing system would do. But this receiver has two channels. One channel, as you can see, the ranging source coming from satellites, so on L1 or L1, L5 in the future, as well as a VDB antenna that is on the vertical fin of the airplane for ILS, for instance, that will capture the VDB signals on which there are the broadcasted corrections and integrity informations to let the aircraft compute position solution corrected with Jibas corrections, as well as to show the deviations of the aircraft with respect to the final approach segment that has been selected for a particular runway, as I showed in this example in particular. And then as last link of the Jibas, of course, there is also a link between the Jibas station and the ATC, because air traffic controller in the tower and terminal maneuvering area, they have to know if the system is working well, which is the level of service that it provides to enable a given approach procedure in the chosen sense of the runway. So on this, so the Jibas, it's a ground-based augmentation system, but GAS, it means Jibas approach service type. This is replacing the more common acronym CAT1 and CAT23, which define the precision of approach procedure with decision I minima. Indeed, going from A to F, the minima decrease from APV1 to CAT3 performance. This means that the decision I, we go from 60 meters for CAT1 until CAT3C class, like ILS, to 15 meters with the runway visual range of less than 220 meters. This means that the pilot at the decision height for a given category has to have in view the runway and then to decide if to land or not. So this is the capability for different approach minima provided by Jibas. So GAST-C is CAT1, it's 60 meters decision high, and then lower than 60 meters, it's GAST-D. So until today on the standard, you will find only GAST-CD for application and not yet what I stated over here, GAST-E and GAST-F. GAST-E and GAST-F are just a prototype service that the Jibas station could provide in the next future, thanks to the dual constellation, dual frequency, using GPS and Galileo and both frequencies. So GAST-E, it's a mode that will use only L5, and GAST-F yet to define if we will use only L1 with dual frequency iono monitor on board the aircraft, or dual frequency combinations of the information on board the aircraft. So which are the benefits of a Jibas installation in aircraft? Reduction of critical and sensitive area for an ILS, but this is something quite old because nowadays the ILS are provided with the most developed antennas that they can already reduce those sensitive areas that can be reused for ground operations. So this is a minimum advantage of Jibas. Jibas, as any other GNSS system, enables you to do curved approaches, provide positioning service. This means that if you are in the coverage area of a Jibas, you can do differential corrections of your position like you would do with Gbas, for example. And then, of course, the deviation in that case are just an indication but not used for precision approach. Indeed, Jibas provision of service is also in several runways. This means that one pilot from the AP documentation for a given approach procedure change on the FMS flight management system, tune this to the frequency or to the channel of Jibas station. This means that it selects not only the frequency of VDB, but it selects also the precision approach procedure on a given runway in a given sense. It means sense, imagine we have north-south runway, we can approach from north or from south, and then we will have the related deviation. Of course, Jibas provide also several approach, glide angles, and displaced thresholds until 49 for each for a given airport. 49 just because this is maximum allowed space that we have in the bandwidth of VDB for message type 4. This means that on a given runway sense, we can land an Airbus 380, as you well know, is a very big aircraft. And then with a given displaced threshold for this aircraft, with a given glide path angle, and as well as on the same runway, for the same sense, we can land a Cessna, for example, a small aircraft that has less stringent requirement, that can land a little bit further in the middle, for example, of the runway, if it's long enough, or this one, and then you can select another approach, precision approach on the same runway. So Jibas can provide also guided missile approach, adjacent airport use. So a given Jibas station can cover more than one airport, not that distance so much, but this will require to have multiple VDB antenna with time division multiple access to avoid destroying messages each other when they are received from the aircraft, if the aircraft is exceed the distance from the two VDB antennas. And something that is very fascinating today, it's about the RFI, radio frequency interference monitoring in an airport. This can be also provided by Jibas station. It's something to which manufacturers and inside Eurocontrol we are thinking to do this. Something not only monitoring the local space weather and to provide a given the information to the ATC and to the aircraft landing, which kind of service is provided in that moment, but also to take in account radio frequency interference. So the Jibas, as is now standardized from December 2018, we have standardized Jibas for Cat1 and Cat3 precision approach with vertical guidance, with the objective of providing several functions. So it provides locally relevant pseudo-range corrections, Jibas related data, for example, troposphere, ionosphere information. This is message type 2 that contain these informations. Those information, they comes from the, for example, the ionosphere threat model. For example, we can't broadcast the same information or Jibas message type 2 in Sao Paulo and Napoli, just because Napoli is far, not that very far from equator, the magnetic equator, but it's that I know in Napoli there are no much ionosphere effect, as well as in the middle latitude of Europe, but in the northern part of Europe, like in Norway, for our colleagues in Norway, they can experience lots of scintillation, and with the Jibas stationing there, it's challenging as would be at your premises, for instance. So Jibas also provide final approach segment data when supporting precision approach. So this means that if the aircraft is flying inside the coverage area of Jibas, like this, for example, can select just the positioning service. So from any point from A to B, that a trajectory that intersect the coverage area, that can do positioning service. But if it does select a final approach segment to land on this sense of the runway, as I have represented here, it will have also the deviation for precision approach. This is the PAR region, PIR, it's precision approach region. And of course, the Jibas also provide ranging source availability data and integrity monitoring for GNSS ranging sources. So here I have summarized generally which are the main messages of the Jibas with the differential corrections, related data, and so on. So we have messages on L1, L1 30 second smoothed pseudo ranges as something new that is CSAR specific. For the information for L5 information, Those are mainly pseudo-range corrections and high rate integrity flag and iono-free information provided. So this is a general scheme that says to you how does it work, the different phases of Jibas for gas CD, EF, a gas F single frequency, and which frequency they do use, and which information of the message they do use. Sorry, I see that I'm running out of time, and then I'm speeding a little bit fast through the slides. And those are commentaries, but you can ask me even later on meaning of those paragraphs here. So the Jibas messenger module is a tool that essentially provide you the possibility to generate Jibas messages without owning a Jibas station. So you would need to set up just an experimental installation Jibas with at least 2 receivers or 3 or better 4 receivers, and then to have another receivers displaced from those one to simulate the aircraft airborne receivers. But instead you can use 4 receivers where one of the reference station unit receivers can play a role of airborne receivers to do this. So starting from those informations, the Jibas messenger that I have developed, the version 2012.03 that Weberton and Professor Gales has, those are developed using the latest standards developed for both GAST CD operational services as well as GAST F, where those information for GAST F airborne processing, not ground yet, as I said before, is provided in Pegasus design justification document. This is under the folder document of Pegasus. And what implement the Jibas messenger is what is stated in Eurocai document 114A as well as the B1, the last standards approved that have been published last year. I believe it was November last year, 2019, sorry. The algorithms, and that is for DFMC processing, the user nav message files, we do use LNAV messages as well as CNAV messages for GPS L1, L5. This is a limitation just because the RINEX standardization group didn't agree yet for a format of RINEX file, and for GPS for CNAV, but for Galileo E1, E5, we use iNav and FNav messages. So the novelty of Jibas messenger that will enable us to analyze many parameters, as I hope to do it, don't running outside of my time schedule, are the provision of ranging information source for each reference receiver, in which here I have grouped is a series of information where mainly I do provide pseudo-range corrections, as those are candidate corrections from the reference station unit. Also the pseudo-range correction broadcast monitor status, and most important for us, for the analysis of which is the impact of ionosphere activity on Jibas, I do provide in the ranging information also code carrier divergence on L1, L5. This is divergence free to understand the code carrier divergence propagation inside the ionosphere as well as multipath. Information is in there that implement a DLR, it's a research laboratory of Germany, provided algorithm, as well as I do provide code minus carrier divergence free informations, ionosphere delay using phase measurements, and as well as the S4 scintillation amplitude parameter. But for the next future, I can add other parameters as like the sigma phi, for example, for for scintillation and the sigma code carrier divergence, but let's see which are the needs from the scientific communities that will give me feedbacks thanks to Professor Galera and Weberton. So here I provide just the receivers that are supported by Jibas messenger. Essentially, those are the receivers that they are supported by Pegasus for experimental analysis of data. But in general, if you have any other receivers that provide Rhinex data observable from format 2.01 to 302, you can do with the Jibas messenger, since the Pegasus converter module is able to handle those information and then to provide Pegasus format data. I would like to jump this slide because it's not really important at the time, since this is just a description of content of messages, message type 1, 11, and 42 for the corrections, that they are essentially on L1 with 100-second smoothing, 30-second smoothing, notably for gas monitoring function on board the aircraft corrections, and then the brand new one, message type 42, that contains the correction on the L5, E5A, and then message type 50, that for the time being does has ionosphere information, so doesn't say yet the message or Jibas messenger to onboard hypothetical aircraft if it has to use or not a satellite, but I would like to address this point with you in our collaboration research activities, since with the CESAR projects we have some doubts, and then your feedback in this collaboration will be really grateful to bring back. So here we go in the core part of the presentation. I'm sorry if I'm late. Professor Weberton, tell me if I'm too late. I can stop whenever you want, otherwise I carry on. I try to go ahead. So at UNESP University, the Jibas DFMC experimental installation is done using 4 receivers, dual frequency, dual constellation, GPS and Galileo, measuring L1 GPS, L2 GPS, and L5 as well, and then E1, E5A of Galileo. So the experimental setup is formed just to generate Jibas messages with the Jibas messenger, so simulate the Jibas station that is equipped just with the 3 reference receivers as shown here, and then the airborne receivers simulated as static at more to let's say receiver place is in there. It's like an aircraft that stands static in there, and then I will just show you what you will be able to do with Pegasus in general, Jibas messenger and the other module of Pegasus. So here we are. So with Jibas messenger, I have got 1 day of data in there, 24 hours of data from the 3 reference receiver station units, and then I have generated Jibas messages and analyzed the performance. On the top you can see the GAD plot. It's a ground accuracy designator plot, which gives an instant glance to the performance of the station. So this says if the curves for sigma pseudo range ground L1 100-second smoothed, 30-second smoothed, and sigma pseudo range ground L5 100-second smoothed are below the ground accuracy designator for class A, B, and C. This means that the station is capable to first address accuracy and then integrity. But as you can see, this plot is shown in function of the elevation angle of satellites. Something to say to you very important is that this is for each bin, elevation bin that goes from 5 degrees to 90 degrees for all satellite, show the curve as interpolated between all the maximum value of the standard deviations for each bin as maximum of all reference station unit of the Jibas station. On the bottom here, I hope you can see it, even there is lots of information, it's a bit tiny. For the same DMC1 RSMU unit on L1 and L5, I did plot the B values, the code minus carrier, the code carrier divergence, and the scintillation parameter. So the B values for GPS and Galileo satellite, GPS is blue and Galileo is green, says how much the pseudo range measurement error on a given satellite for a given RSMU contributes to the pseudo range correction medium value that is effectively broadcasted. Essentially, this can be seen in another way. The B values for a given reference station monitoring unit says to you the health of this receiver, how well the measurements are done. But here, as you can see, as the elevation increase from 5 degrees to 9 days, we are unfortunately, just for the moment, just because we are initial status of this experiment installation at UNESCO University, we have a strong background of multipath and noise. Indeed, as you can see here, for B values, we have jumping values that they are going outside the nominal value, because those are very small ones of around 0.05 meters, and here we are 10 order of magnitude bigger, but this doesn't mean that it's a bad station, it's not that bad. But as we can see, we have strong contribution from multipath as CMC and code carrier divergence. They do show us decreasing from 5 degrees to 90 degrees when we do elevation. Something I have to state here, the S4 parameter, I'm sorry, there are some limitations because the sampling period of RSMUs are 2 Hz and not 50 Hz as nominally should be done. But the specification to compute the scintillation amplitude parameters, I've got this from the ICAO Ionosphere Study Task Force meeting number 3 that specify how to use it. And it's like the standard deviation of the intensity of signal. In that case, is code to noise ratio. It's not signal to noise ratio, divided by the average of the code to noise ratio on a sliding window of 1 minute. This means that each point in those plots means that is computed during the standard deviation normalized by the average over on a 1 minute's window interval. So I'm sorry for this limitation, but this is the current status of data format is in there. So, but here from even the S4 doesn't meet the general, the nominal standard of computations, we can see that below 30 degrees, it's not reliable, but after, I don't know yet, I will have to see with you, of course. So let's go, because I'm already very late, I'm sorry for this. So, which are the effect of local biases, such as multipath scintillation and noise? Those that do let trigger the broadcast monitor. So from the output of Pegasus Jibas messenger, we have also the monitor broadcast that it says during that period of time. This is early in the morning. In the morning, the broadcast monitor flagged not broadcastable pseudo range corrections and integrity information on both L1 smoothed 100 second, 30 second, as well as L5 for 100 seconds smoothed. But this, what does impact? Does impact immediately the broadcast message type 1. That is the most important message for L1 to provide at least the GAST C. As you can see, when broadcast monitor trigger, this means that the information for one or more satellites can't be broadcasted to the aircraft. So this will degrade the geometry and then, of course, also the performance on board the aircraft. This means less availability, so higher protection level, because the geometry will decrease, and then even bad information concerning the B values This means for the capability or protection level of overbounding the position errors. So what I tried to do, sorry, yes, I do jump, I did go too fast. So to analyze which is the scintillation impact of a satellite on a given day, this was 17 November 2019, where here PRN8 was impacted by scintillation. And I'm sorry for my analysis because my background of those things are limited, since in Europe we don't have much ionosphere. This is my first time ever in my long career on analyzing it. It's just autodidactic one, and please correct me if I'm wrong in any of those analyses. What I could analysis here is that we can see we have a strong multipath because the signal to noise ratio, high variability until 22 degrees. But as I know very well from your colleagues, our colleagues over there, Weberton and Professor Galera, and I had a look a lot on the EP website of my friend Eurico too, and starting to have a look from 30 degrees elevation angle. In there, even my S4 parameter calculated, I don't know if it's well, it is flagging something, a moderate, if I understand well, around 0.5, 0.65 values when there is high variability in the amplitude or intensity of the signal. But at the same time, we can see that this was not the CMC, even the background of multipath is quite high, but at the same time, the code carrier divergence was showing some, let's say, variations, but this is not really good. Next time, I mean, for the CCD output, I would like to output the standard deviation of the CCD. So this plot is just to show you that when there is ionosphere scintillation, the broadcast monitor, as I have implemented it, triggers on L1, not on L130 and L5. So this means that the correction for that satellites in that period of times, they were not broadcasted. So in that case, to look like the ground station monitor was providing good information, so denying the aircraft to use the same satellites with some ionosphere inside. So another example here is much more detailed. This is for PRN27 on 17 November 2019, where here I plotted L1 and L5 signal to noise ratio, as well as scintillation CCD B values. And the most important plot here, this is something to which us at CNS Lab Eurocontrol, we were looking very much. Essentially here, to resume, it's that the L5 that is in red and the L1 is green for that satellite GPS 27 is higher than the L1 is. This is thanks to the fact that the reference station monitoring unit, the L5, is a bit stronger than L1 is against multipath. So the power of signal on L5, it's a little bit higher, but as well as you can tell me, because I have to learn from you about those kind of things. Propagation, L5 is worse than L1 on propagating through the ionosphere, and here notably I can see that through my limited computation of S4, L5, S4 on L5, it's still a little bit higher than is the S4 on L1, as well as the other parameters. So as we can see that in correspondence of scintillations where we have signal to noise, code to noise ratio fading, we have a variation of pseudo range correction of order of 0.2 meters per second in there. But in that case, I can assure you that broadcast monitor didn't detect this. So in this case, the aircraft would use the pseudo range corrections with a given epsilon due to a given epsilon for this reference receiver station unit. This is candidate pseudo range corrections to be broadcasted. And then here, lastly, for the B values, we can see finally the effect of smoothing filter, accumulating the error over the time on a window of 100-second smoothing and 30-second smoothing. As we can see here, the effect on L1, it's higher than the L5 that is always in red. So I have just the 3 slides to conclude. So I tried to, at the same time with Pegasus, to analyze the performance on board an hypothetical aircraft that is located at more to place of the receivers. This is a static one, and here I have plotted the Stanford plot that gives us a glance on the performance that put in relation the protection level on the y-axis and x-axis the position error. As you can see here, for GAST-C performance analysis in there, so we have high accuracy for horizontal, at least less than 2 meters, but protection level are very well below 40 meters alert limit, as well as for vertical. For vertical, we do have high accuracy, but we have to take in account that in either we are with the receiver more to very close to the Jibas configuration, and even there is lots of multipath background and noise, we still have very high correlated, at least atmosphere, space weather correlated effect between Jibas station and aircraft. But this is good enough to understand what happened in there. But what we can see, our station as preliminary results, unfortunately, provide 48 misleading informations in the horizontal domain and 4 at least for Cat1 in GAST-C. Misleading information is a case where protection level doesn't overbound the position error. So the true position error is higher than the protection level. So this means that will be not alerted on board the aircraft. So we will have to exclude those absolutely, but for experimental use and the research, it's that okay. So for that I did, as well as for GAST-D and GAST-F of those. So for GAST-D, we can see that situation about misleading information, it's a little bit better. We pass from 48 to 31 misleading information, but for the vertical, as vertical component is more sensible, we have 5 misleading information about this. But as you can see, the spots, what I would like to show you, that GAST-D provide better performance than GAST-C, since the spot, the density of the point is a bit lower than GAST-C is in there, just a little bit of this information. And then finally, the GAST-F, using dual frequency, dual constellation. This is the prototype service in use, where really I'm surprised I have just 1 misleading information for GAST-F in horizontal and vertical domain. But as you can see, compared to GAST-D, the spot of the point of density is higher. This means that protection level for GAST-F are higher than GAST-D1, a little bit higher if you can. And this is due to the fact that on the GAST-F we do code carrier measurements, and with dual frequency we have interfrequency bias that is most to it's 1.87, that it comes from linear combination of L1, L5 to suppress the ionosphere, but at the same time, unfortunately, we do multiply the background noise and multipath for a factor of 2. That's why, so the protection level of GAST-F are really high with respect to GAST-D and GAST-C, but the future of GAST-F would be mostly GAST-F single frequency L1 using high redundancy of satellite, so better geometry of the satellite with the dual frequency Iono monitor on board, and I hope one day to develop with you, for example, a monitor on the ground side and then to transmit when a satellite should not be used due to scintillation or ionosphere gradient and so on. So just to conclude, I'm very sorry, I'm overrunning the time. And the Pegasus training course didn't take place this year, of course, due to the COVID situation, but in general, if you would like to participate to a full Pegasus training course on Gbas and Jibas, it's a full week at the Eurocontrol Institute of Air Navigation Services. It's not in Paris, France, where I work, but it's in Luxembourg. And then I will be very pleased to have you in my classroom and to give you more insight about Pegasus. But don't forget our rendezvous that will be in March, and this will be Professor Galera to give you the appointment for this one, and hopefully we can do it. And in general, if you wish to contact myself or Eurocontrol in general support on Pegasus, this is the email. Please write down, it's pegasussupport@eurocontrol.in for any information about the training course as well as support with Pegasus. So I thank you very much for your patience and to listening to me. And now I'm at your disposal for your questions. Hopefully it will be still possible. Otherwise, I leave the floor to Weverton and Professor Galera, to the next speaker, and I can answer even later if you want. Thank you very much for your attention.
Thank you, Natalie, for this very great presentation. Weverton had some problem with the internet connection, and then I will end up your talk here. It was a very nice presentation from what we are working here, this challenger with Gbas used in Brazil. We have a lot of questions, but due to the time, I will put one, and we will ask for the people to send you the question later on. But there is one from Vinicius Istuan. He's from Technical University of Paraná. And he asking about Natalie, what would be the best way to make precision approach feasible in Brazil? Since the sigma VIC values are very high, mainly the short crest of the anomaly. And he also saying another one, probably he wants to say is the sigma VIG is used for all satellites, the same value, and how about to use the sigma value for each satellite? And the screening satellite to estimate HPL and VPL or other methodology.
So thank you very much, Vinicius, for your questions. So this is a very challenging question but I'm sorry, sigma VIG, it's about the old GAST-D version. We have passed over. Now we have a new dual sigma ionosphere gradient monitor that has been approved last December this is in 2018, the new document, 253 D version. So the sigma VIC, it's not used anymore. We have other two parameters in replace of this. This is Epsilon EIG and Epsilon EIG. I'm sorry, I don't remember all those acronyms. I will maybe send an email to Vinicius. Vinicius, if you are interested in more details, I can give you even the document. So the sigma VIG for GAST-D, it's not yet in either. We have a more better Iono monitor on board the aircraft, and studies have been done in the ionosphere working group of Jibas of this. I don't participate all the time, and sincerely, I don't know yet the results about this. But what I can tell to you is that the current version of Pegasus that is delivered and I have uses still the no, that doesn't use anymore the Sigma Vig. I have already updated to the new D Sigma Iono monitor. So which is the best approach, which is the best service to use in Brazil with high ionosphere? Sincerely, I would like to tell you with the Gbas probably. Gbas single frequency, L1 with dual ionosphere monitor on board the aircraft, or maybe a monitor inside the station. This is because first, we can lower the level of noise that we are obliged to multiply by interfrequency bias 1.8 if we will use ionosphere free. So we use L1. We profit from the redundancy of satellites, and then ground and airborne could do the monitors. For example, scintillation that is seen from ground could be not the case for the airborne. No, correct me, Professor Galera, if I'm wrong on those kind of things. So we just need to have double redundant monitor, ground and airborne. So the answer is something like ni. Need means yes and no. Still have to see. And I would like to see with Professor Galera and Weberton, all the research team in there, if we can do it, because until now, this has been a little bit far from Pegasus team. So let's see. I would like to do that, but as we have seen with the Gbas, we have just one misleading information. It's not that bad. And protection level are well below 40 and 10 meters horizontal and vertical. So hope I did not answer too much on the side and not on the objective. And if any of you in the audience would like to have more details, please write me, or we can have even another teleconference after Christmas holiday. If you want, we can do that.
Thank you, Natalie. We have more questions here, some from the INPE people, but we need to stop here and would like to say thank you very much. And I also would like to say here that Eurico de Paula is also watching you. And he said, Natalie, to see you and thanks for your excellent presentation. And so I also would like to say that next year, probably in March, Natalie will provide us with one training here at UNESCO, and we'll make this information available to those that will be interested. Thank you, Natalie.
Thanks to you.
It was a big pleasure to have you here with us.
Thank you very much. Merry Christmas, and especially take care for the next year and healthy 2021 to everybody. Ciao.
Thank you.
Ciao. Ciao. Bye.